How do you add and subtract radicals? What about multiplication? And what happens if you have a radical in the denominator? Let's find out.
To simplify this radical expression, the first step is to get rid of this exponent. Now, I can't just apply the exponent inside because there's subtraction, so I have to rewrite it as the entire expression times itself. Next, we just want to expand using FOIL, so my first term times my first term. That would give me, well, you do the coefficient, so 3 times 3, and you also multiply the terms under the square root with each other. So root 3 times root 3, that actually just gives us 3, or root 9, which is 3. Now I'll do my first term times my second part of the second bracket, so minus 3 root 3. Then again, I have minus 1 times root 3, which is minus 3 root 3, and then minus 1 times minus 1, the two negatives cancel out, we're left with plus 1. Now, because both of these terms here have root 3, we can add those terms together because they're considered like terms. So I'm going to have 27 minus 6 root 3 plus 1. So my final answer will be 28 minus 6 root 3. In order to simplify this question, we need to simplify each of these radicals so that we can collect like radicals. So we need to ask ourselves, what times what equals what's under the radical? And one of those numbers should ideally be a perfect square, because square and square roots cancel out. So I'm going to rewrite 48 as 16 times 3 minus 4 times 8, I'm going to rewrite as 4 times 2 plus 4 times, well, 27 is 9 times 3 plus 4, and 50 is 25 times 2. So 16, 4, 9, and 25 are all perfect squares. So I can rewrite them, so 16 is the same as 4 squared. And 4 is the same as 2 squared. 9 is 3 squared. And this is why I picked these numbers. And 25 is 5 squared. And now the square and the square roots all cancel out here. So we're left with 3 times 4, which is 12 root 3, minus 4 times 2, which is minus 8 root 2, plus 4 times 3, so plus 12 root 3, plus 20 root 2. Now we can go ahead and add our like radicals. So both these radicals have root 3, both these terms, so that would be 24 root 3, because you add the coefficients, or the numbers not under the radical, and we can also add minus 8 plus 20, which is plus 12 root 2. To solve this question, I need to get rid of the radical in the denominator, or rationalize the denominator. To do this, I'm going to multiply the top and the bottom by 5 root 5. So when I multiply the top, both terms are multiplied by 5 root 5. So I'm going to end up with 5, and then root 5 times root 5 gives us 5. So 5 times 5 minus 4 times 5, which is 20, times root 375, divided by 5 times 5 is 25, times 5. So here we have 25 minus 20, and I'm going to rewrite root 375 as, well, if you divide by 25, which is a perfect square, you could rewrite it as 5 squared, or 25, times 15, all over 125. Then we have 25 minus 20 times 5, because when you take it out, the square and the square root cancel out. So minus 100 root 15 divided by 125. Now, we're almost at our final answer. The final thing that I notice is that all of the coefficients are divisible by 25. So I can take 25 out of the top and the bottom. So if we divide everything by 25, we're left with 1 minus 4 root 15 divided by 5. And this is our final answer. In order to solve this question, we also have to rationalize the denominator. So to do that, we don't just multiply by the denominator itself, we actually multiply by the conjugate binomial, or the opposite binomial. So it's going to be root 15 minus root 12, root 15 minus root 12. In the numerator, we got 15 minus root 180. And in the denominator, which we're trying to eliminate the radicals, we'll get 15 minus root 180 plus root 180 minus 12. So as you can see, those two terms cancel out, and we're left with 15 minus 12. So we can rewrite this as 15 minus root 180 over 3.
Thanks for watching. See you in the next video.